Welcome to this video tutorial about the R package CodemetaR. In this video, we are going to see why it's very useful and quite important for R developers to include a CodemetaR file in their own R packages in order to improve the way they specify the package's metadata. And above all, we are going to see that it's an easy thing to do thanks to the package CodemetaR. First of all, I must say that I'm not an author of this R package. I'm only a regular user and a SWH Ambassador. Thus, we will not showcase every single feature of the CodemetaR package because there is already a complete and well-written documentation for that. Instead, we will focus on the most essential features that allow for an easy creation of a CodemetaR file for your package and try to convince you that you should give it a try. But before we dig into the technical details, just some words about software metadata in general and why keeping them organized and up to date is important. For instance, if you are a researcher, you may want to make all your analysis reproducible by your reviewers and readers when you submit or publish a research article. For that, the metadata of the software or packages you used are crucial, since they indicate the version and dependencies other people will need to run your analysis in the exact same way as you did. Software metadata also include information about how to cite a software, which is another important information for you when writing your article. But above all, organized and structured metadata considerably enhance software discoverability. Search engines will be able to find them more easily and to link them to some useful keywords. Similarly, popular software repositories such as GitHub would be much less easy to use if there were no metadata in the software hosted in these repositories. For all these reasons, and probably many other ones, any software developer in general, and any R developer in particular, should care about the way they specify metadata in the packages they create. So let's start with some quick reminders about the canonical built-in way to specify all the necessary metadata when you create an R package. You can see here the file tree of the R package vegan, here hosted on GitHub. In all those files, there is a very specific file called description, where you can find all the usual metadata about the R package. Its name, a complete list of authors in a specific format, the dependencies of this R package, and many other information such as an URL for the GitHub repo, the license, and so on. This description file has a very specific format or syntax, and a template of description file can be generated using built-in R functions or the R package DevTools. Note that in addition to this mandatory file, other information can be available in a less structured way, but maybe richer way in a README file, as it is the case here. The problem is that this description file is R-specific, and that other programming languages also have their own style, their own format, their own requirements for specifying packages metadata. For instance, you can see here an example of Julia package, which is called mesh.io. In its file tree, you have a file project.toml, which is kind of a philosophical equivalent of a description file in R. You also have the package name, its author, the license, the software dependencies, and so on. But you can see that its syntax is really different from the syntax of a description file in R. Similarly, you can see here an example of Emacs package, which is called CyTAR. In this language, the language Emacs Lisp, the metadata are located in the header of the main file, which is called citar.el. And once again, you have the name, the author, the license, etc., but in another very different format. Therefore, for each programming language, you have a language-specific way of indicating your metadata when you create a package. And this is actually kind of a problem. Because of that, it's quite difficult to harvest automatically the software metadata, because you need each time a language-specific process to do so. As we already mentioned earlier, it's typically a problem for search engines, for instance, or for all software archives or repositories. That's why the CodemetaR project was created. The idea is to provide a unified, universal format for describing software which will not be language-specific anymore. By generating a CodemetaJSON file, you turn your metadata into a format that can easily crosswalk between many different programming languages. You have here an example of a CodemetaJSON file. We are in the GitHub repo of the R package rpolyhedra. Note that this CodemetaJSON file is simply placed at the root of the package directory just along with the description file. And since it's not a standard file to build an R package, since those CodemetaJSON files do not belong to the R universe specifically, you may simply add this file to the R build ignore list so that it can be skipped when the package is built. So the format or the syntax used by this CodemetaJSON file is a kind of a JSON-like syntax, as you can see here. You can find once more the package name, its authors, the URL, and so on. But as you can see here, this JSON formatting is quite heavy, quite hard to read for a human, and even more difficult to type by yourself, by hand. So obviously you won't type, you won't write these files yourself. Several options do exist to generate automatically such files for you. The first solution is to use the website created by the team behind the CodemetaR project. On this website, you just have to fill in at least part of the available fields, and a CodemetaJSON file will be generated accordingly. This is very easy to use, and this is a convenient way to create such files for your R packages. However, there are some questions that are not fully addressed if you choose this method. For instance, you will have to update manually your CodemetaJSON file for each new version of your R package. You might even forget to do so and simply let an outdated CodemetaJSON file live in your R package file tree. Part of these issues are addressed by a new version, or rather a fork, of the CodemetaR generator that you can see here. It's still under development as I am speaking, but a new feature is that you can automatically fill in all the fields by submitting just a GitHub or GitLab URL. This is a nice improvement because you don't have to type everything by hand, but it's still something you can do only once the software is already created and hosted on a given repo, and you will still have to update manually your file for each new version. So you might feel the need for another tool, and that's where the R package CodemetaR comes into play. With this R package CodemetaR, you will be able to generate a new codemeta.json file for your package and to parse, modify, or update an already existing file. So let's see how to use it in practice. So first of all, the R package CodemetaR is available on CRAN so that you can install it using the usual instruction install packages. So just install packages CodemetaR to install it. And you can, of course, load it using the usual instruction library. Here I placed my R session in the file tree of an R package, as you can see here. So we are in the file tree of an R package, and of course this package has a valid description file that is just open here. We can easily generate the corresponding codemeta.json file with the following instruction. You just have to call the function write codemeta. And that's it. Let's just open the codemeta file that has just been created. As you can see, all useful metadata have been extracted from the description file and automatically placed in this codemeta.json file. Note that CodemetaR can also read and extract some other information coming from the README file. If you have any badges in it, for instance, badges indicating the service used for continuous integration, or the minimal R version required and so on, then the R package CodemetaR can also extract such metadata. And furthermore, as you can see here, the file codemeta.json has also been added automatically in the R build ignore file so that it will not be considered when building the R package. It won't raise any problem. Once the CodemetaR file has been generated, it's important to make sure that it will be updated accordingly during the life cycle of your package. For instance, when you release a new version, welcome a new cursor, or change the development platform, like move from GitHub to GitLab or stuff like that. There are several options for that. First, if your package is hosted on CRAN and if you use DevTools, then it will be the easiest option. In this case, you probably use the following function, DevTools release, to submit a new version of your package to the CRAN. Well, the good news is that this function will automatically check whether your codemeta.json file is up to date. I mean, contains the same metadata as your description file. And it will warn you if this is not the case. So you'll never forget to update your codemeta file when submitting to CRAN.